Good afternoon. We're just going to do a quick review on blood cells. For those who were absent for SOLs, let's just do a recap to make sure that you guys understand the basics before we move on. So blood cells, another name for blood cells or red blood cells would be erythrocytes. All right. The shape of a red blood cell, you guys need to know, is biconcave. And what biconcave looks like is basically like a frisbee. It's concaved on both sides, or kind of like a donut. They are very small. The diameter is 7.5 micromilliliters. That fancy M is for micro. All right. Then we have, you guys have 4 to 6 million red blood cells per milliliter of blood. Then you have something called spectrin. Spectrin is going to be a protein that can actually change the shape of the red blood cell molecule. The reason why you guys would want to change the shape again is because, remember, we have those smaller blood vessels, which are capillaries. In order for a red blood cell to fit into a smaller area, it has to be transformed. So the shape will be transformed due to this molecule right here, spectrin. All right, the reason why we need red blood cells, they transport our oxygen, our O2. We also have something called hemoglobin. Hemoglobin is something that's going to attach onto that red blood cell, and it's going to act as a magnet for oxygen. So it's going to hold on to the oxygen for you. So remember when we were talking earlier during the school year, or excuse me, earlier in March, about how people that have sickle cell, they have a transformed shaped red blood cell, so it looks like a waxing crescent. So they don't have enough surface area to carry a lot of hemoglobin, meaning that they don't have enough surface area to carry hemoglobin. That means they are lacking a lot of oxygen. And remember, oxygen is what we need for our muscles to make sure that they aren't hurting, and people that usually have sickle cell are in a lot of pain because they are not getting enough oxygen to their muscles. All right, so one hemoglobin can carry up to 4 oxygen cells. Make sure you know that. That's very important for your tests. Then the process of actually making blood is called hematopoiesis. We already talked about that also when we talked about bones. It happens in the red bone marrow. Remember, red bone marrow can be found in spongy bone and then also in the epiphysis regions of the long bones, which would be those ends of the long bones. So hematopoiesis, the word poiesis means formation, and hemato means blood. So blood formations. All right, and remember the process of hematopoiesis, blood cells do not divide. They're not like meiosis and mitosis where they can go through a cycle. They actually come from a stem cell, which is hematopoietic stem cell. And remember, anything that starts off as a stem cell always starts as an immature cell, which is a blast. And once it develops into a mature cell, it becomes a cyte. So osteoblast, well, remember that's like bone cells, but if they talk about erythroblast, that would be like your red blood cells, the immature form. So erythrocyte would be a mature blood cell. Then moving on to this category, we have leukocytes. Remember, leukocytes are broken down into 2 categories. They have granulocytes, meaning that they have granules. Those are those little dots in the pictures, and we're going to get ready to go over those in a moment. And then we have agranulocytes, meaning that they don't have any granules present. The ones that have granules are going to all end in phils. The suffix is going to be phils. Neutrophils, eosinophils, and basophils. Then you have agranulocytes. They just end in the word cyte, monocyte, and then you have lymphocytes. All right, so before we even get into all the different white blood cells, make sure you remember this acronym, no longer making everything boring for white blood cells. This is going from the most abundant white blood cell to the least abundant. Neutrophils are going to be your most abundant. And then you got lymphocytes, monocytes, eosinophils, and then basophils. All right, so make sure you have that written down. Your 2 types of blood cells. And remember another key point. White blood cell leukocytes, they are known as true cells, which we're going to move down here. They're called true because they actually have a nucleus. So they're complete cells or true cells. Remember, your blood range for white blood cells should be in the range for when you go get a CBC, which is a complete blood count. you will be in the range of 4,800 to 10,800 white blood cells milliliter per blood. If you are greater than 11,000 white blood cells, that's going to indicate that you have some type of infection going on. Your body's trying to fight off that infection to get back into homeostasis. Remember your internal balance, which is 98.6. All right, leukocytes. Remember, they represent less than 1% of blood. All right, because remember, it's a part of the Buffy coat. Buffy coat contains your platelets and it also contains your white blood cells. Together, they make up less than 1%. That other 55%, remember, that's going to be your plasma. Plasma is at the very top because it's least dense. And then at the very bottom, remember you guys had erythrocytes. They represent 45%, so let's make sure we don't forget that. So granulocytes and agranulocytes. We're going to get ready to go into those categories. So we have granulocytes. Let's start with neutrophils. So remember I said neutrophils are the most abundant white blood cell. As you can see, they represent 50 to 70% of all white blood cells. They fight off bacterial infections. All right, so like staph infection or strep throat, these will be the fighters in there. They are 2 times bigger than red blood cells. Their nucleus can have 3 to 6 lobes. So this picture is only showing you a nucleus. This here is the nucleus. It only has 3 lobes. But remember, if you see a nucleus that has 4 to 5, it's also going to be a neutrophil because it can have anywhere from 3 to 6. Those little dots are those granules I was talking about. Granulocytes are going to be the ones that have the dots present. Moving on to eosinophils. They represent 2 to 4% of all white blood cells. Their job is to fight off parasitic infections. All right? Tapeworm, hookworm, any of those type of infections. They're the same size as the neutrophils. Remember, neutrophils are 2 times bigger than red blood cells. They have a 2-lobed nucleus, and this is what they look like. They kind of look like a horseshoe. Little horseshoe, and then they also have those granules. Then we have basophils. They're going to be your rarest white blood cell. Remember, no longer making everything boring. They're at the bottom. They're the least abundant. They only represent 0.5 to 1% of white blood cells. Their job is to release histamine during inflammation. So these are the ones that are going to be present more during like an allergic reaction when it releases that histamine to calm down inflammation. And they're U-shaped. So notice they don't have those little dots or lobes at the end. They're just a basic U shape. That's how you're going to identify them. And then they have granules also. So these 3 are going to be your granulocytes. And they're going to have granules. And they all end in phils. And make sure you know their number range and what their job is to do. All right, so then we have agranulocytes. Those are going to be those big eaters. The first one we have is monocytes. Monocytes represent 3 to 8% of all white blood cells. They're the largest white blood cell out of all of them. They are also U-shaped, but they're a thicker U-shape, as you can see. They're going to be the ones that's going to help with chronic infections and viruses. Monocytes are macrophage. The word macro means big or large, and phage means to eat. So they're the big eaters. They're the big eaters when it comes to these chronic infections. All right, notice there's no dots. Agranulocytes, no granules are going to be present, no granule cells. So this is what a monocyte looks like. Then we have our last one, which is going to be lymphocyte. Lymphocyte is going to be 25% of all white blood cells. Their nucleus, the way you're going to indicate this one, it's going to take up most of the cell. Lymphocytes, they develop in those lymph tissues. Remember, you can find lymph tissues underneath the neck, underneath the armpits, in the groin area. All right? They're going to be the ones that's going to indicate an immune infection, something going on in the immune system. There's 2 types of lymphocytes. You have your T cells. T cells are going to be the ones that act on the viruses. And then you have B cells. These are the ones that are going to develop those antibodies that are going to help also fight off infections. All right? So the way you can remember B cells and antibodies, there's a B in antibodies. T cells are going to be the ones that are going to do the viruses. All right. So let's get back to our slogan. You can do no longer making everything boring, or never let monkeys eat bananas. Most abundant, 50 to 70% is your neutrophils. 25% will be your lymphocyte. 3 to 8% will be your monocytes. 2 to 4% will be your eosinophils, and 0.5 to 1% will be your basophils, which is the rarest form. And that's going to be the abundant to least abundant. All right, so that's just a recap on you guys' blood cell notes. And feel free to pause the video at any time if you need to make any additional notes.